Good afternoon, good evening, or good morning. I'm Catherine Willett, Senior Director of Science and Regulatory Affairs at Humane Society International. I'd like to thank the organizers for inviting us to present today. And I'm going to tell you about one of our flagship programs under the Animal-Free Safety Assessment Collaboration umbrella. And this one is about cosmetics. And it's about implementing animal-free safety assessment of cosmetics globally. First, let me tell you a little bit about Humane Society International and our department, which is the Research and Toxicology Department. And then I'm going to give you an overview of our AFSA program and the cosmetics work stream. And particularly, this talk is focusing on the cosmetics education and training program. I will give you a brief description of the program and the materials that we're developing, and then I'll cap that off with the status and next steps for this program. So the Humane Society International and its partner organizations, which are the Humane Society of the United States and the Humane Society Legislative Fund, are the largest force for animal protection around the world. In our science team in particular, in the Research and Toxicology Department, brings together experts in human and environmental toxicology, regulatory science, public policy, law, biomedicine, and all the other ways in which animals are used in science. And critically, the Humane Society in general, and our department in particular, works in cooperation with the stakeholders involved in animal testing and science to effect change that works for everyone. And this includes the regulators, the lawmakers, regulated industry, method developers, and other stakeholders in this group. Because most of us are professionally trained and have professional backgrounds, we have stakeholder status with a lot of groups, including government and corporate advisory bodies, particularly in the areas of chemical and product safety and alternative methods, etc. We have for many, many years worked closely with the OECD on test method development. HSI has offices all around the world. These are where we have country offices, so in-country people on the ground that can really best affect change because they live there and are from there and know how things operate. So you can see we have a pretty broad reach globally. So our Research and Toxicology Department, we have recently combined all of our toxicology related projects under one umbrella that we are calling Animal-Free Safety Assessment Collaboration. And this, right now, this collaboration is focused in 4 areas. The one I'm going to talk to you about today is focused on cosmetics. We also have a project that we call Tox 21, which is about promoting the paradigm change in safety assessment and creating the infrastructure for that in terms of looking at pathways of toxicity and knowledge base. That program really supports the OECD AOP program. We have one project on chemicals that's pretty focused right now on read across, acceptance of read across under REACH. So that's mostly European at the moment. And then we have a vaccines project, which is looking at harmonizing best practices for vaccine safety globally. In the cosmetics work stream, these are the partners that are working with us to affect this change and to create the educational materials that I'll be talking about today. So when I talk about the teams of experts who are developing the materials, they are scientists from our members, and the members shown here, which are, of course, are some of the largest international companies that are really on the forefront of developing these techniques and approaches. the AFSA Cosmetics project has two pieces. One is a policy piece and the other is the science piece. And we feel they complement each other very well. So the policy piece is focused on policy alignment, and that is bringing regulatory frameworks in different countries in alignment with the situation in the European Union in terms of the animal testing and sales restrictions on cosmetics that have been tested on animals. That's to create a level playing field. And there's also, because there is a lot of consumer demand for this, people really want to be able to know that their cosmetics and personal care products are not tested on animals. And so the point of that side of the project is to really enforce, which is the momentum building that will create a completely animal-free safety assessment world for cosmetics and personal care products. Then the other part of this program is the science piece, which we at the moment are focusing on an education and training program. And that is to make the animal-free safety assessment world practicable for industry and for consumers to ensure consumer safety without the use of animals. So as I said, the AFSA Cosmetics Education and Training Program is really to support innovation without new animal testing. And it focuses on some well-established processes, including that these assessments are risk-based safety decisions, they're exposure-led, and they're product and use specific, and really rely on sort of an iterative decision-making framework. And in this case, the materials are built on sharing relevant experience and expertise from our members, including a lot of case examples for how you do all of this. This program, the intent of this program is to be disseminated in a way that will really support regional capacity building to achieve this long-term acceptance of non-animal safety assessment, and to address the needs of the regulated and regulated communities, as well as other stakeholders, CROs and consultants. And so when I talk about how we're rolling out this program, it's really designed to meet the needs of various stakeholders. So it will also be a kind of an iterative process. This program is built on well-established principles and processes. The first are the next generation risk assessment principles that were developed by the International Cooperation on Cosmetics Regulation, which is a group of regulators from Brazil, Canada, the EU, Japan, and now Korea and Taiwan, as well as the US. And so these regulators, in collaboration with some of their industry partners, sat down and created these 9 principles for what a good consumer product safety assessment looks like. And the principles, there are 4 principles that are sort of overarching that the whole process should follow. And that is that the goal is human safety. The assessment, as I mentioned, is exposure-led. And it's really hypothesis-driven. And critically, the assessment is designed to prevent harm. And that is opposed to what we've been doing historically, which is trying to predict toxicity, particularly in an animal. This is really designed to prevent harm from human exposure. There are 3 principles that govern the risk assessment process itself. As I mentioned, it's a tiered and iterative approach, and it really follows on gathering all existing information and appraising that information, and seeing whether or not whether or not, and if so, what additional information you need to make this decision. And of course, any testing that is done is based on robust and relevant methods for the purpose. And then the final two principles are really important. They're about documenting the whole process transparently and explicitly, and also capturing the uncertainty at each step of the process and then in the decision-making overall. These are two steps that are often, shall we say, less well developed than some of the other steps. And so they're very critical, particularly for regulatory acceptance. The other major thing that this program is based on is the workflow that was created by the Surat Framework Program. It's a European Framework Program project. And that is the Surat project was safety evaluation, ultimately replacing animal testing. And in this project, they came up with a workflow for actually doing the assessment piece itself. It's a three-tiered workflow. Tier 1 begins with the first, characterizing the substance that you are looking at, and then collecting all existing information about that substance and its exposure, and then evaluating that to see if there is a method you can use to make a decision at that point. If not, then you want to develop the hypothesis and create some information about the bioactivity through predictive modeling or in silico tools, and see whether or not you can you have enough confidence now to make a decision. And if not, then you need to create new information through an ab initio in vitro testing strategy. And this is designed for purpose. And then you do it iteratively or apply it iteratively until you have the information that you need to make the decision. We have taken these things and put them together in a risk assessment flow, which is shown in the blue boxes along the top. And just very generally, it's the process really starts, as I mentioned, with collecting the existing information. And then because it's exposure driven, you then look at the exposure and try to characterize it as well as you can and see if you can make a decision just simply based on the amount of exposure to an individual or population. If you need information about the biological activity, then you characterize the biological activity of your substance. And finally, if the exposure and the bioactivity are pretty near to each other and you would like more information about the possibility of some biological activity internally, then you want to refine the exposure by looking at internal exposure. And then finally, how do you put this all together in a risk assessment conclusion that is well documented? So that's the overall flow. And what we've done is break this flow up into 8 different pieces that we're calling modules for development. And these modules are really based on the expertise and tools that you use to do each piece, and that they are somewhat separable, although slightly overlapping functions within the risk assessment process. So in our program, we have 2 modules that deal with existing information. One is on the problem formulation. So that's how you set up the question, what goes into it, how you decide whether or not, where you go next. And then another module on the history of safe use, which is concerned with biologicals and how you characterize them and then determine whether you can make a decision about their safe use based on the history of the mother product or similar substance. Under exposure estimation, we have 2 modules dealing with that. One is on consumer exposure and how you do that. What is the data that you need that goes into that? Where can you find the data? That sort of thing. Then there's a module on exposure-based waiving, which is for things that are not that are at very, very low levels in products, you may be able to show that they're safe regardless of what their bioactivity might be. Under biological characterization, we have two modules, one that's all about the predictive modeling, so all the in silico tools, and then another module on how you take the information from in vitro assays and put it together to answer questions about bioactivity. And critically, this is not about how to do the assays. There are lots of programs out there, classes and courses that will show you how to do the assays. So what distinguishes this program is it's really about how to use the information to make decisions. So it's meant to be complementary to things that are already out there. And then should you need to further refine the exposure, there's a module on internal exposure and how that is done. So that's PBK modeling, also in vitro to in vivo extrapolation. And then finally, there's a module on how you put this all together into a risk assessment. So these 8 modules will constitute the entire program. Now I'm going to go over a little bit what is in each module. I've sort of told you at a very high level how we've broken up the pieces. And so now I'm going to just tell you also at a very high level what is in each module. So the first module on problem formulation really talks about how you set up the whole risk assessment, how you figure out what you need to focus on, how to hone in on the use and exposure pathways. You begin to formulate a hypothesis at this point. Also it's about collecting and evaluating all of your existing information and considering bias in possible sources of bias when you're setting up this problem. The next module on history of safe use is, as I mentioned, really about biologicals and how you compare them. Our member companies have a lot of expertise in this area, and so this is about their experience and their processes of how they do this. And it has to do with really characterizing your substance, identifying a comparator and characterizing that, and then looking at the possible ways that you can evaluate the exposure and any kind of hazard based on existing information. And then finally, coming up with a decision and how you would capture the uncertainty around that particular decision. The module on consumer exposure really deals with what goes into estimating consumer exposure and measuring consumer exposure, and how you talk about habits and practices and where you would find information about these things. There's a lot of information looking at that have collected data on the habits and practices of different populations for different product types, and you can those are all published. And then how you take this information and apply models to it to come up with various estimates from the initial sort of more simple modeling, deterministic modeling, which will give you a single point estimate for your exposure. Or if you would like more realistic information, you can apply a more complex modeling approach, probabilistic modeling, which takes a range of data and turns it into a range of possible exposures. And this is very good if you are critically concerned with dealing with the sensitive populations. Then there's a section on how you approach aggregate exposure, which is exposure to the same substance from multiple different product types. And then what do you do with this? What do you do with the exposure estimates in the risk assessments? Where do you go next? The module on exposure-based waiving is focused on products that are on substances that are in products at extremely low levels and for which you don't know very much. And can you actually make a reasonably safe determination simply based on low exposure? And there are established ways of doing this. And that is, this module talks about the concept of toxicological threshold of concern, and also talks about how to apply this to different routes of exposure. The predictive chemistry module begins with an introduction to the in silico tools. So that's QSAR and SAR and different approaches. And then how you estimate the quality of your model, and also how you determine applicability domains and that you're using your model properly. And then there's a section in here on read across and the frameworks that our members use to performing and documenting a well-substantiated read across. And this includes capturing confidence and uncertainty. And the in vitro assay synthesis module, as I mentioned, really is talking about how you take the information from the assays and combine them to make decisions. And this module includes a survey of the different kinds of assays that are out there, but it really focuses on the main bioactivities that you need to know for consumer products, and how you approach that, the different ways that you can combine information to come up with answers and examples, case examples of each of these. And finally, how you take all of this and put it into a next generation risk assessment to come up with an overall conclusion about the biological activity of your substance. The internal exposure module, as I mentioned, if you need to further refine based on your exposure and bioactivity, comparing those, then you can further look at what your substance does internally, also by predictive modeling or modeling actual data. So this involves physiologically based modeling and different approaches. So this module explains what's behind the different modeling approaches and what information goes into them, what the different approaches actually do, and then the applications for the different modeling approaches, and critically how they sort of fit into the risk assessment. There's also a section in here on in vitro to in vivo extrapolation, so that you can actually look at in vitro points of departure that are comparable to in vivo concentrations. And then finally, the final module is about how you put this all together into a risk assessment and capture all the assumptions you made, all the uncertainties, and what the uncertainty is in the overall risk decision. Okay, those are the modules. I'm just going to talk a little bit about our process and where we are. So all of these modules are being developed by a team of scientists from our members. And these are people who have vast experience in each part of this methodology. And so they're developing the content and also providing case examples for each of the steps that I talked about. There are case examples for how you go through each of this. We have an education expert on board who is helping us with the educational design. And that is that all of these are based around learning objectives. We have our target audiences in mind when designing the learning objectives, and we have different sets for different target audiences. And we want to make sure that the whole point of this is to help people be able to use this in their daily life. So we want them to walk away with the tools that they would need to be able to do this. So that's why learning objectives are very critical. And then we have a graphic designer involved in making all the presentations presentable, and also look the same and have a consistent presentation approach and format. The goal of this is eventually to turn it into a web-based platform that people can do in a self-paced way that has quizzes and exams and ultimately a certification at the end when you're done. And of course, all of this is free and would be accessible to everyone via the web. Where are we now? We are in the midst of the module development. So our science teams are busy creating the modules. A few of the modules, as you can imagine, they're at different stages because it's a complex, team effort. And so they're about half of the modules are just about finished with their first drafts. Once we get the drafts, we put them into the presentation creation mode, where we will create shareable presentations in a PowerPoint format first. And what we want to do is to take those drafts and then share them with some of our key stakeholder groups and get feedback from that, because the goal of this is really to provide tools that meet the needs of our stakeholder audiences. And so we need to have some initial discussions to get feedback and make sure that our materials are addressing their needs. Then the modules will be revised based on that feedback, and then more or less finalized. I mean, I'm sure we'll fine tune them as we go along, but we want to have them fairly well finalized before we really disseminate them out into the world. And that would start toward the end of this year and really beginning in 2022, when we'll really be rolling out this program. And I imagine about halfway through 2022, we will have the full program available. So that is our plan. And for you, if anyone in the audience here is interested in providing feedback to us on these modules, please get in touch with me. And we're very interested in getting feedback from as many stakeholder types as possible. So that is the end of my presentation. And thank you all very much for your attention.